Okay, so this is non-right triangles. I believe we have some vectors here. Yes, vectors, non-right triangles. So we're going to be looking at law of sines, law of cosines, and vectors in this video of the review stations. So, station one. Station one is, well, you tell me, is this when they give me big C is 145 degrees, and little b is 4, and little c is 14. Have I been given a situation where I'm using law of sines or law of cosines? So let's think about that. Okay, so if I have 145 degrees here, and this is 14, and let's say we know that this side is 4. Well, what I see here is I don't have side, 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 and I don't have side angle side. So I don't think I'm using law of cosines. And look, I've got an opposite side angle pair. And whenever I have an opposite side angle pair, I think about, well, that's law of sines. So I'm going to start with law of sines and say sine of 145 over 14 will equal the sine of b over 4. Of course, I'm looking for b, so I'm going to start by multiplying both sides by 4. This is the sine of b, so let's get our calculator going, and these are degrees, so I'm going to change from radians to degrees. Please make sure you check. 4 sine 145, and I want to divide that by 14. So this decimal number here is my, hello, there we go. This decimal number here is what all this stuff is, but I need to get it b, so I'm going to do second inverse sine, second answer. And I get 9.432 degrees. So 9.432 degrees, that's fabulous. To find this angle, I'm just going to subtract these from 180. 180 minus that last one, minus 145. And this ends up being 25.568 degrees. And finally, I'm going to use law of sines a second time to find little a. So I'm going to say little a over the sine of 25.65656788156. That's right, I don't round until I get to the end. Equals 14 over sine of 145. So let's solve for a by multiplying both sides by the sine of this angle, sine of that angle, and I'm multiplying both sides by that, so times 14, and divided by the sine of 145, and I get little a is 10.534. 10.534 is my answer there. Fabulous. Okay, so there's one. Let's take a look at 2. Problem 2 for station 1 says a is 58 degrees, and little a is 11.4, and little b is 12.8. Again, I've got an opposite side angle pair, so I think I'm using law of sines. I definitely find that the graphic organizer helps me do these problems. You maybe don't need it, but me, yeah, I often find that it's really helpful both as a place to organize the information, but also helps me figure out what I still need to find. So this is 12.8. We're calling this b over here. And I guess this is big C and little c. So I know the side opposite pair. I know this side, so first I'm going to try and find that angle. So the sine of beta is what we're looking for. That's going to be sine of 58 over 11.4. And again, all I really have to do here is multiply both sides by 12.8. And then inverse sine. So let's see where that goes. We've got 12.8 times the sine of 58 divided by 11.4. So this decimal number is in fact the sine of b. But I want to know what b is, so I have to get the inverse sine of both sides to get b by itself. 0.95219435336. Okay, so inverse sine of that, and something happened. Let's try again. 12.8 times sine of 58 divided by 11.4. Okay, so yeah, I can have a sine value that's 0.95. I just can't have anything bigger than 1. So let's see what happens. Inverse sine, second answer. Okay, I got that b is 72.212 degrees. And so to find big C, I'm going to do 180 minus A minus B. So minus that one, and I get 49.788 degrees here. And now if I need to find that side, if only this were a right triangle, I could use Pythagorean theorem. But since it's not, I'm going to use the law of sines again and say C over sine of 49.787, 82051 equals the 11.4 over sine of 58. Okay, so I want to solve for C. I'm going to multiply both sides by the sine of that. So 11.4 times the sine of that last answer divided by sine of 58. And I get that little c is 10.266. All right. Well, so there's our first station. Well, but wait a minute. Isn't it the case that when we have law of sines, there might be the ambiguous solution? Well, I did a great job of seeing if there was one solution. I solved the one triangle. What about solving that other triangle? Does the other triangle, that other solution, really exist? Well, let's think about it. So what was that recipe? The first angle we find. Okay. So if there's a b prime, then 180 minus b has to be greater than 0. Well, oh, no, sorry. Minus b plus the given angle, right? Plus the given 58. All right, well, let's see what we've got. We've got 180 minus 72.212 minus 58. Well, that's looking like that's going to be a positive number. 180 minus 72.212 minus 58. Look at that. I've got a b prime, 49.788. Okay, so now that I know that there's this b prime, I need to go about finding my second solution. And remember, the second solution is going to keep all that original given information, but we will have these other bits change. So this is now 49.788. And I can use the angle sum theorem to say that all three of these angles should add up to 180. So if I do 180 minus the 58 that was given, minus my b prime, second answer, I end up with 72.212 here. That's very interesting. And so now, when I find little c, yeah, hold on a second. I feel like I've done a mischief here. So this one is not b prime. Okay, let's go back again and say b prime is, there we go. That's b prime. So I know that B was 72.212, and if I do 180 minus 72.212, I'm going to end up with B prime is 107.788. Great. Now, is there a second solution? Well, let's test for that second solution, 788 degrees. If I add B prime plus A, is there room for a third angle there? Is there room for C prime? So C prime is 180 minus B prime minus that given angle, 58 degrees. So if I do 180 minus my B prime minus my 58, I end up with C prime being 14.212 degrees. 14.212 degrees. And now to find little c, I'm just going to use my law of sines and say that 11.4 over sine of 58 should equal little c prime over the sine of 14.212. Excellent. So let's do the sine of 14.212 and multiply that by 11.4 and divide by the sine of 58. And I end up with 3.3. And there's my c prime. So I really do have two solutions here. And guess what? No one's going to remind me of that when I go to take a test. So please make sure you're comfortable with that. Okay, station 2. Station 2 seems to be about triangle area. Remember, we have two recipes for that. We have the side, side, side recipe. That's Heron's formula. S A, there we go, is S minus A, S minus B, S minus C. Okay, and what's S? Well, remember, S is the semi-perimeter. It's A plus B plus C divided by 2. All right, so in our situation, I have A, B, and C. And so I think, I do in number 2. So I think number 2 is going to be side, side, side with Heron's formula. But we have another formula, side angle side, and that was area equals 1/2 AB sine C kind of thing. Though we also saw that we could write it as BC sine A kind of thing. And so that's in fact what I see in problem number 1. I have the two sides and one angle. So for problem number 1, I'm using this method, and I'm saying that the area is going to be 1/2 A times B times the sine of 84. Well, okay, so I'm going to do 160 times the sine of 84, and I forgot the sine, so 160 times sine of 84 gives me the area is 159.124 units squared. Whereas in number 2, I have to use Heron's formula, which means I really need to find the semi-perimeter. A is 6, B is 9, C is 7, not divided by 3, divided by 2. Okay, so 15 plus 7, I believe, is 22. Let's just confirm that, because there's nothing sillier than making a mistake that you can't fix. Good, and if I divide by 2, I get 11. So I know what S is now, and I can jump into my Heron's formula and say that I want 11, 11 minus 6, 11 minus 9, 11 minus 7. So square root of 11 times 5 times 4 times 2. 8 times 5 is 40. 40 times 11 is 440. Okay. I could do some simplifying here, but since I have to, I don't know, I definitely feel like having a decimal approximation here. So what is the square root of 440? I get 20.976 units squared. Okay, that's station 2. Station 3. Station 3, well, I've got an angle, 43, and I've got a side, 4/9, and a side, 7/9. Hey, look, no opposite side angle pair. So this tells me when the directions say solve the triangle, this tells me that I'm going to be using law of cosines here for this problem, okay? I want to use law of cosines. So we recall our cosines. I think I'm going to start with 43 degrees for C. Let's go with 7/9. So there's big B, and 4/9. With big A over here. Yeah, I often like getting that side angle pair. So I'm going to look for little c. So I'm going to do c squared equals a squared plus b squared minus 2ab cosine c. Okay, so 4/9 squared plus 7/9 squared minus 2 times 4/9 times 7/9 times the cosine of 43. Well, as soon as I see the cosine of 43, I know I'm doing this on the calculator, so I'm just going to pull out my calculator and be very careful here. Cosine of 43 times 7/9 times 4/9 times 2. Okay, so I have that number, and now I want 4/9 squared plus 7/9 squared minus that number. And this is c squared 0.296841885. Let's take the square root of that. So answer, dope. Square root, answer, and I get 0.5448. And because this is law of cosines, I don't have to check for that second solution. I can just use what I've got here to find now this angle and this angle. There are a lot of people who, once they get that side angle pair, they switch back to long sines. But remember, we had some problems with that in that law of cosines video. And so to avoid that, I'm just going to use law of cosines to find this angle or to find this angle. I think I'll do this angle next with law of cosines. So I could certainly set this up as cosine A equals b squared plus c squared all over 2bc. So let's see what happens there. Here's my b, so 7/9 squared plus c, that's that number there, squared. And I'm going to divide that answer by 2 times 7/9. Let's go 7/9 times my c value. Okay. Cosine A equals 0.642857. If we do the inverse cosine of both sides, I end up with ba. inverse cosine of that answer. And it looks like A is 49.995 degrees. That's not what I got for A. Yeah, okay. Well, it's good to check your work. And so let's think about this. We know that C squared equals A squared plus B squared minus 2AB cosine C. Okay, and oh, that's what I forgot on top. C squared minus A squared minus B squared over negative 2AB is going to be cosine C. And I'll get rid of this by changing these. So that, and that's gone. Okay, that feels a little different. So let's take a look. We've got our C as 0.554. 8. Okay. So A squared, that's 4/9 squared, plus 7/9 squared, minus C squared, minus 0.5448 squared. And I want to divide that by 2 times 4, 7/9. 7/9. And A 4/9. And I end up with 0.7314. The inverse cosine of this answer. I get a number that I still don't have up here. That's very strange. What's happening here? What am I missing? Yeah, we both got that. So, yeah, well, that's very, very confusing. So, hold on a second while I figure out what's going on here. You know, it's good to check your work. Okay. A squared plus B squared. Yeah, C squared is A squared plus B squared minus 2AB cosine C. So there's nothing wrong with that. So this should be a rewritten version. That's just fine. We subtracted these. Or I could add this and subtract that, and that'll get me here. Okay, well, maybe I typed in wrong. That's often an issue for students, so it could certainly be for me. I'm going to have 4/9 squared plus 7/9 squared minus 0.5448 squared. Here's my numerator, divided by 2 times 4/9 times 7/9, close parentheses. Well, let's just confirm that. That's AB. That's A, and that is B. Oh, but wait, that's cosine C. I know C already. So, yeah, that's where my issue is. Okay, thank you for your patience. So I'm looking for big B. All right, so I know that big B is going to be A squared minus C squared, plus C squared minus B squared over 2AC will give me cosine of B. Phew, now it feels better. All right, thinking. it's a big, important thing. I encourage it. So we're going to have our 4/9. Yeah, I don't know how people do it without drawing the graphic organizer like that. It's just crazy to me. So we've got 4/9 squared plus C. Here's our C. 0.5448 squared minus B squared 7/9 squared. And then I'm going to take that number and divide by a whole bunch of stuff, so don't forget parentheses, 2 times our A value, which is 4/9, times our C value, which is 0.5448, and close those parentheses. I end up with cosine B equals negative 0.2283873. 226. Well, that's what cosine B is, but I want to know B, so I have to do the inverse cosine of both sides. And when I do that, of both sides, I end up with 103.202 degrees. Now I'll take these away from 180 to find this angle. We can certainly use law of cosines yet again. Minus 40, minus that answer, minus 43, and I end up with 33.798 degrees. Well, that took a little while. Thanks for your patience with that. Oh my goodness. And then what about our next problem? Well, our next problem is side, side, side. So again, I know I've got only one solution to find, or maybe it's no solution, but no ambiguous case, no two possible solutions. That only comes with law of sines. So here's big A and 55, here's big B and 25, and big C with 72. So C squared, cosine C will equal A squared plus B squared minus C squared over 2AB. All right, let's go. There's our A, 55 squared plus 25 squared minus 72 squared. I end up with negative 1534 on top. And on the bottom, 2 times 55 times 25 second answer divided by, whoa, that's not what I want. I want second answer parentheses. Okay. So I get that cosine C turns out to be negative 0.5578. If I do the inverse cosine of both sides, I end up with this being 123.905 degrees. Okay, so there's my big C. Good. And what about this angle? Well, so that would be cosine A equals B squared plus C squared minus A squared over 2BC. All right, so 25 squared plus 72 squared minus 55 squared. And I want to divide that number, which, by the way, turned out to be 2784. I'm going to divide that by 2 times our B value times our C value. Insert. And I end up with cosine of A is 0.77333 and a whole bunch of 3's. So if we do inverse cosine there, we get A equals 39.346 degrees. And so let's find B by subtracting these from 180. 180 minus that answer, 123.905, and subtract this answer, 39.346. And so I end up with 16.749 degrees. Yeah, nice. Remember, across from the smallest side should be the smallest angle. Across from the biggest angle should be the biggest side. I think that's about as far as checking I go with these problems. Station 4. So station 4 looks like a bearing problem. A boat is sailing east parallel to a beach. So here's our beach, and here's our boat. The boat is sailing parallel to the beach. The first time it sights the lighthouse, the bearing, so this is a lighthouse, the bearing from the boat to the lighthouse is south 70 east. So it goes south and 70 degrees to the east. Okay, but 10 minutes later, the ship checked its bearing a second time, and that's the second sighting, and the bearing was south 63 degrees east. And we're asked the question, how far is the ship from the beach? Well, that's interesting. I thought they were going to ask me this, but they didn't. In fact, they say, what's this distance? Okay, well, I do see this non-right triangle, and I see this right triangle. So I think what I'm going to have to do is something about finding this side here, because then I'll know a side and an angle in a right triangle, and I'll be able to use the side and the angle to find the missing side. Okay, so let's take a look. This part is 63, there's 90. So I know this whole angle is 153 degrees. 90 plus 63 is 153. Do I know any sides? Well, I've got 10 miles an hour. That's my rate, and the time, 10 minutes. Well, 10 minutes seems like something if I multiply by my rate, except, oh, look, this is in hours, and this is in minutes. So I'm going to have to convert one of these. 1 hour is 60 minutes. So minutes can cancel, and hours can cancel. And now I'm going to be able to find miles. It's going to be 10 times 10 divided by 60. So 100 over 60 is 5/3 of a mile. So this length here is 5/3. All right, so what do I know? Well, I've got an angle, I've got a side, but I still don't yet necessarily know if I'm doing law of sines or law of cosines. And I'm feeling a little struggling with how do I find the missing angle there? I see here a right angle. And this is 70, so that's got to be 20. And now what do I have? I have an angle, I have a side, I have an angle. And because I have these two angles, I could subtract from 180, and I would get 7 degrees for that one. And now I have an opposite side angle pair. So I can say that 5/3 over sine of 7 is equal to, what are we calling this? Little b2. Little b2 over sine of 153. So if I multiply both sides by sine of 153, I can figure out what this length is. Well, let's start with that. 5/3, and I want to multiply by sine of 153. And I want to divide that number by the sine of 7. And I get 6.208705256. And these miles, yeah, miles. Okay, so this distance, the distance from the boat to the lighthouse on first sighting, was, a little more than 6 miles. Now I'm looking at this triangle. I'm looking in the big triangle here. It's a right triangle. I know the hypotenuse, I know this angle, and I'm looking for the side that's adjacent there. And so whenever I think about adjacent and hypotenuse, I'm thinking about cosine. And that's going to be d over this 6.2087. So if I multiply both sides by this number, I'll figure out what d is. So I'm going to take that answer and multiply by the cosine of 70, and I end up with 2.124 miles from the beach. All right, and just checking my work. Yep, looks great. Okay, so there was station 4. How about station 5? What can we say about that? Oh, it's a vectory problem. So two forces act on a point, one with 200 pounds at 30 degrees, and there's another one with 170 pounds at negative 45 degrees. And that one is 170 pounds. Okay, find the component form of the resultant force, its magnitude, and direction angle. Well, great. So I find that when I add these together, I'm going to end up with something that looks like that. But you know, this one's longer than this one, and so maybe it's supposed to actually be over there. So let's just be mindful of that, and then just really basically recognize that this is just adding vectors together. We're going to use that form where we have our magnitude, cosine 30 sine 30 plus 170 cosine negative 45 sine negative 45. And you know, when I think about these problems, I think, well, yeah, they're all fully unit circle values, so I feel like I'm supposed to be using unit circle values. So that's going to be the cosine of 30 is √3/2, and the sine of 30 is 1/2. And here I have 170, the cosine of negative 45 is positive √2/2, comma negative √2/2. And then I'm going to do that distributing on the way to adding, and that's going to give me 100√3, comma 100 Earth. And half of 170, isn't that 85? Is 85, good, 85√2, and minus 85√2. And then I get to this place and I say, okay, I'm going to add those values. And so I'm going to have 100√3 plus 85√2, comma 100 minus 85√2. And I'm going to feel a little frustrated with this component form. That's capital T truth, but I'm going to pull out the calculator anyway because I want to have a sense of how big that number is. 100 square root of 3 plus 85 square root of 2. And I get 293.4132338, comma 100 minus 85 square root of 2. And that gives me negative 20.2081528. Fabulous. Okay, so that's the resultant vector in component form. We also wanted the magnitude of r, so I'm going to use the Pythagorean theorem with these values. I'm going to say that that one squared plus 293.4132338 squared. And if I take the square root of that answer, I'll get 294.108 pounds is the resulting force. Certainly those forces acting together to make an even bigger resultant force. But now let's see if we can figure out whether or not my that dotted line I drew at the beginning, whether that was correct or not. Is my theta r positive or negative? So let's take a look at that. We know that in this situation we use tangent. We know that the tangent of this over this, I'm sorry, the tangent of theta equals this over this over this. So I know that theta, not Q, theta is tangent inverse of negative 20.20851. Oops, 81528 over 293.4132338. And so let's see what we get. Inverse tangent of 20.2081528. And I want to divide that number by this 293.4132338. Okay, and I get theta equals negative 3.940 degrees as my resultant vector. And that's great. So my first picture was in fact correct. All right, now don't forget vector addition. We'll see that on our test. Plane flies, oh, this is station 6, by the way. Plane flies 650 miles per hour on a bearing of north 20 east. So there's my plane. It's going 650 miles per hour, and this is 20 degrees. A 30-mile-an-hour wind blows 10 north, 10 west. Okay, so we've got 10 degrees here. And this is our wind, and it's a 30-mile-an-hour wind. Not degrees, but miles per hour. And we want to know what the new heading or bearing for the plane is. So when we think about adding these, we end up with this sort of parallelogram. You see the plane is going in a different direction than it had been originally. So we'd like to know what is this new direction, and to figure that out, we can just do the same thing that we saw in station 5, where we say 30 cosine. Well, now be careful, because that's the angle for cosine, not this one. So if this one's 20, this one must be 70. So we have cosine 70, sine 70, and now we want, oops, the plane, 650. That's better, because the angle to the wind is 90 plus 10, or 100. So cosine 100, sine 100. All right, remember, past here, cosine is going to be negative. So don't be surprised when that's a negative number. And I need 650 cosine 70 plus 30 cosine 100. That's going to be the x component of my resultant vector. And then my y component, well, it's going to be 650 sine 70 plus 30 sine 100. Okay, well, let's see what we get. 650 cosine 70, close that parenthesis, plus 30 cosine 100. I end up with 217.1036478, comma, 650 sine 70, close parentheses, plus 30 sine 100. And I get 640.3444361. All right, well, that's my component form, but what do we want? Well, we want to know the heading, so I need to find that angle. What direction angle is this? Well, we know that theta is just going to be tangent inverse of this y value over this x value. So let's take that number and divide it by 217.1036478. And now I need the inverse tangent of that. And I end up with theta being 71.271 degrees. And so I could say my bearing is now this way, east, 71.271 degrees north. But most people prefer to go north first, and so I actually have to find that angle. Well, the way I find that angle is I take 90 degrees and I subtract that angle to get this. So if I do 90 minus this angle, I end up with, whoa, not 90 times, 90 minus 71.27118, 362. And I end up with north 18.729 degrees east. Okay, so I hope you have one of those answers. Yeah, normally we go east first. Station 7. 2 ships leave port at 10 a.m. One travels north 58 west. That's one of them. At 12 miles per hour. The other one goes south 67 west. Huh. 67 west. That's 67. This one is 58. So this must be 32. And this must be 23. Huh, well that's definitely not a right angle, is it? Yeah, that's going to be 55 degrees there. Okay. And this ship was going 16 miles per hour. What is the distance between the ships at 1 p.m.? So I want to know the distance between these two ships at 1 p.m. We started at 10 a.m. We're stopping at 1 p.m. That's 3 hours. So this one goes 12 miles an hour for 3 hours. So that's going to be 36. And this one's going 16 miles an hour for 3 hours. And so that's going to be 48 miles. Okay, so I know a side, an angle, and a side. To me, that sounds a lot like law of cosines. And we are looking for this distance. So t squared will be 36 squared plus 48 squared minus 2 times 36 times 48 cosine of 55 degrees. Well, that's pretty straightforward. Well, let's find out what we get. 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of 55. Remember, this number is d squared, so don't forget to take the square root of that number, and you should end up with d equals 40.221 miles. All right, now to station 7. How about station 8? What do we get with station 8? Station 8, town B is directly south of town A. We've got that. We've got this. A, B, C. We're told that 235 miles. This is 178 miles. And this is 273 miles. And we're asked to find what is the bearing from town A to town C. Well, I like south this amount of degrees west. But how many degrees is that? Well, I can use law of cosines here. I can say that 235 squared plus 178 squared minus 273 squared all over 2 times 235 times 178. Well, that's going to be the cosine of angle A. Watch out, make sure that when you type this into your calculators, everything in the numerator is in parentheses, as well as everything in the denominator needs to be in parentheses. 235 squared plus 178 squared minus 273 squared. And I'm going to divide that by 2 times 235 times 178. And I get 0.1479799, and I need not that, because that's the cosine of A. I need A. So I'm going to do inverse cosine of that angle. And I get that angle A is 81.49012201 degrees. Well, that's great. So if I'm thinking about the bearing, and we're asked here to find the bearing from, I did A to C just now, but we also need from B to C. Okay, so what's my bearing? Well, I'm going to be heading south, 81.490 degrees west. Yeah, and that's my bearing from A to C. But what if I'm going from B to C? Well, I think I'm going to do the same sort of thing. I'm going to find this angle phi by using my law of cosines again. And so what do we have? This time we have 273 squared plus 178 squared minus 235 squared over 2 times 273 times 178. All right, well, let's see what we get. I've got 273 squared, and I've got a plus 178 squared, and don't forget to subtract the 235 squared. Don't forget parentheses around everything at the top, and parentheses around everything on the bottom. 2 times 273 times 178, close parentheses, and I get a number for cosine of phi. If I do inverse cosine of that angle, I end up with 58.356 degrees. And so what's my bearing? Well, now my bearing is north that many degrees. So we're going to say north 58.356 degrees west. And that's going to be the bearing from town B to town C. Got to go north that many degrees west. All right. Nice. Station 9. Station 9, we're told that U is 2, 1, and V is 1, 3. Find W. W is what we get when we add these. 3, 4. Good. And now we're asked to draw. Okay, so I'm going to draw U. U goes over 2 and up 1. And when I get to the end of U, I'm going to draw a V. V goes over 1 and up 3. Remember, I could also draw a V, go over 1 and up 3, and then draw U, go over 2 more and up 1. So this is U, this is U, this is V, this is V, and W. W is that resultant vector. All right. Wow, that's all I had to do for 1. What about 2? 2 says we want 2U. Well, 2U is going to be 4, 2. And we want minus 3V. So 3V, 3, 9, and we want to subtract. Okay, so I subtract. I get 1, negative 7. That's my resultant vector W. And again, they want me to draw these things. Okay, so we know that this is U, so 2U says, hey, go over 1, 2, 3, 4. 2, go over 4 and up 2. That's my 2U. But now I'm supposed to subtract 3V. So 3V would be go over 3 and up 9. That's 3V, but we want minus 3V. So that's going to go like that. That's minus 3V. And so go over 3 and up 1. No, over 4 and up 2. So that's 2U. And here, this is going to be too far. This one's going to be minus 3V because we could also go 2U minus 3V. Okay, So where does that take me? Well, that takes me to a place where my resultant vector is actually that one. And that's, that's going to be, if it were an ordered pair, 1, -7, which is pretty close to what I thought it would be. Great. So that's station number 9. Let's take a look at station 10 and see what we can do there. Sorry, someone supposed to meet me in Zoom to go over some problems. Okay, station 10. Let's see if we can knock this out. Find the angle between the two given vectors. I'm told that v is 3i minus 2j, and w is 2i plus 2j. We want the angle between these. All right, so if I think about these, one of them goes over 2 and up 2. It's w, 2, and v goes over 3, but down 2. There's v, 3, -2, and we're looking for that angle. So there's a bunch of different ways to do this problem. For a long time, I used to think it would be nifty for me to use the law of cosines here. I've thought a lot of different things, but recently I'll say, instead of me, students. The students seem to prefer doing this. And so they say, okay, I know that this is 3 and that's -2, and they use this information to find that angle. And say this is 2 and this is 2, and they use that information to find that angle, and then they have those two things together. Yeah, I'll do that. So this is inverse tan over 1. Oh, great, because 2 over 2 is 1. That means that phi is going to be 45 degrees. And then what about this one? Inverse tangent of -2 divided by 3. Inverse tangent -2 divided by 3. And I get theta is -33.69 degrees. But we want to add these two quantities. That's a positive. So plus 45. And I get 78.69 degrees is what's between those two vectors. All right, find the component form of the vector, given magnitude, and given direction. The direction of 1, 3. Okay, so we've got over 1 up 3, over 1 up 3. Here's our vector, and if I do the Pythagorean theorem here, I get square root of 10, which is a little bigger than 3, isn't it? Square root of 9 would be exactly 3, but we don't want to go 3. Ours says we want to go 2, so we only want to go this far, which means that this and this have to be shorter. All right, so let's think about this. Well, I know that I plus 3j divided by, let's call that vector u. If I divide by the magnitude of u, now I'm going to have the unit vector in that direction. And that's equal to, let's just stop there. And so this is 5 over root 10 plus 3 over root 10. Okay, so that's the unit vector in the direction. but I want to go twice that. Yeah, I want 2 times this amount. So I'm thinking that equals my v over magnitude of v. There we go. So if I multiply both sides by 2, I'm going to have v. So I'm going to have 2 root 10 over 10, and 6 root 10 over 10. And these can reduce to root 10 over 5, comma, 3 root 10 over 2. Is that right? Yes, it's over 5. There we go. So there's my v. Okay, that was station 10. How about station, it was not Mr. Cooper, you skipped one there. Go back and do that, come on. Okay, so how about this approach? We have a direction angle. So v cosine theta v sine theta v. And we know all these bits, don't we? We know the magnitude of v is 3 root 2, the cosine of 150, the sine of 150. So cosine of 150, that's negative root 3 over 2. Sine of 150 is 1/2. We just have to do some distributing here. Minus 3 root 6 over 2, comma 3 root 2 over 2. And there's my v. Okay? That's v in the direction of 150 with a given magnitude. And our magnitude in this problem was that 3 root 2. You can certainly decimalize this, negative 3.67, comma 2. Okay, there's station 10 complete. Station 11. Station 11 says find the unit vector in the direction of v. Well, v is 6i minus 2j, and we know that v divided by the magnitude of v is going to give us the unit vector. Well, the magnitude here is going to be 6 squared plus negative 2 squared. Take the square root. That's our magnitude of v. So that's 36 plus 4, so square root of 40, or 2 root 10. It doesn't ask for component form. We were given i's and j's, so I sort of feel like I should give my answer in i's and j's. So 6i over 2 root 10 minus 2j over 2 root 10. I can do a little simplifying here and get 3i root 10 over 10 minus, the 2's cancel, root 10 over 10j. Fabulous. That's part A. And part B. Part B, we're given component form. I still want to use v over magnitude of v to find the unit vector. Here we have 5, negative 12. And the magnitude, if you don't recognize the Pythagorean triple here, 5, 12, 13, you could certainly use the Pythagorean theorem to find that magnitude. And so I know that the unit vector in this direction will be 5/13, comma, negative 12/13. And there's our component form. Excellent. What's part number 2 say? 2 says, find v with the given magnitude in the direction of u. Oh, yeah, we just did that in station 10. So we know that v over magnitude of v equals u over magnitude of u. And if we're looking for v, that means I have to multiply both sides by the magnitude of v. So v is going to be u for 6 times the magnitude of v over the magnitude of u. Well, to find the magnitude of u, I have to use the Pythagorean theorem to find what am I going to get here? It's 36 and 16. It looks like the square root of 52, which is 2 root 13. So 2 root 13. Well, I guess I can take this a little further, do some canceling. I'm going to have 8 over root 13, comma 12 over root 13. And for those of you who support the not yet everybody who likes to rationalize are dead yet people, let's rationalize this to 8 root 13 over 13 and 12 root 13 over 13. And there's v. That seemed pretty straightforward. And then the last one I see here is going to use the same method, that v is going to be u times the magnitude of v over the magnitude of u. And so what's that going to look like? Well, that's going to be negative 3, 3. 3 squared is 9, 3 squared is 9, 9 plus 9 is 18, square root of 18 is 3 root 2. And don't forget to multiply by the magnitude of u, which here is 6. Okay, do a little canceling, do a little distributing. I get negative 6 over root 2, comma 6 over root 2. And again, if you'd like to rationalize, that's going to be negative 3 root 2, comma 3 root 2. Yeah, because here, look, when you do that, this is going to be 2, and so I can cancel it 2, and that's where those came from. And so there's v. All right, last station, station 12, a bearing problem, of course. We've got a triangle here. And putting my compass rose here at A. We've got 100 compass rose here at B. And let's see what it is. Find the distance from town B to town C. I want to know that distance. If the bearing from B to C is south 41 west, and the bearing from A to C is south 28 east. Uh-oh. This would be south 28 west. So now I'm going to modify my picture a little bit. No worries. I can do that. So C is now over here. Okay, so we will head south and 28 east. Okay, so we want to know the bearing from A to B. I want to know this bearing. Well, I need to find that angle. Let's see how we can do it. Well, we see a right angle over here. If this is 41, then that has to be 49. I feel like I should be using that 28, so I'm not going to use that 28. I'm just using that 100. That's pretty exciting. And therefore, Oh, duh. Hold on a second. I missed this important piece of information. No wonder I'm stuck. The bearing from A to B, this very angle, no, I'm not looking for it. They've given it to me. They say that's 74. So I can do 74 minus 28 to find this angle here. So let's see what that'll be. 74 minus 28, and that's 46. Okay, so now I know that that's 46, and oh, guess what? This is parallel to that. And so I know that these parallel lines cut by this transversal, I'm getting that this is 74, and so this must be 46, I think. That's 46. Oh, because there's my diagonal. That's 46. Okay, so what is it that we're actually looking for here? We'll find the distance from B to C. All right, so I'm looking for distance. Okay, well, I've got plenty of angles now, right? So it's like 95 degrees here, and that's 46 degrees, and we have the 100 in between. Do I have an opposite side angle pair? Well, if I know those, 51, so this is 29 degrees. I guess I can do 100 over sine 29 equals d over sine of 46. All right, well, let's see what happens when we do the sine of 46 times 100 divided by the sine of 29. And I get that that distance is 148.376. And do we know if these are miles? These are miles. Okay. And that's not at all the answer that I had. Oh my goodness. Okay. Well, and you know that's what happens when you rush things. So let's try and do this a little more carefully the second time, because I really need to get to that zoom. Okay, so we're heading this way. We've got 100, and we're heading this way. And that is 28. So this one is 74. This one is 46. Here, and here. And so we've got C. This is us going south, 41. This must be 49. So this was 46. Why is that 46? Because that one's 74. That one's 74. That's not 46. That's 16. That's probably where my mistake was. So this whole angle is 65 degrees. There we go. So 65 and 46 is 111. And so this must be 69 degrees here. Now we've got it. So 100 over sine of 69 equals d over sine of 46. Excellent, excellent. And what should we end up with? Well, let's see, 100 sine of 46 divided by sine of 69. And I get 77.052 miles. Alrighty, well, I hope that was helpful, and good luck on your next assessment. Take care, everyone.